All right, welcome to today's video. We're going to be talking about antiderivatives in today's video from section 4.1. So to start us off, I'm going to ask you a question. If I were to give you f prime of x equals to 3x squared and ask what function f of x had this derivative, what would you say? Hopefully you said x cubed. And you may have said x cubed plus a constant. So for example, you might have said f of x is equal to x cubed plus 1. And you would certainly be right. But you would also be right if you said f of x is equal to x cubed minus 700. You would also be right if you said x cubed plus any arbitrary constant. And so usually the way that we account for this is we say that the integral, that's what this symbol represents, the integral of the function 3x squared dx is equal to x cubed plus c. And so today we're going to talk about general ways to find what is called an antiderivative. So you can see I've already filled in your first couple of vocabulary words. We say that f of x is called the antiderivative of f prime of x. And the symbol integral of g of x dx, and notice that there are no numbers on this integral, is what we call an indefinite integral. And the term indefinite integral is a synonym for antiderivative. Okay, so in the next big box on the first page here of your notes, I've got a list of a bunch of the basic antiderivative rules, and they're basically just stemming from differentiation rules. And so I'm going to point out a couple of these that I think are important, and the first one that I think is important is the first one. And so I'm going to say here on the left side, hey, what are the two things that we have to do in order to take the derivative of x to the n? And what you would say is that you would say we would multiply by the exponent n, and then the second thing we would do is we would subtract from n by 1. Now, if we want to go the other direction and take the antiderivative of x to the n, then we have to completely undo what we do in the derivative process. And we've got to do it in the opposite order. Because if you think about it, this is sort of the illustration that I always use. If I start at a point A and I want to go to point B, let's say I go south first and then I go east. Well, if I want to go back the exact same way, I've got to undo going east first, and then I've got to undo going south second. And so what that means is that when I take the antiderivative, the first thing I'm actually going to do is I'm going to undo the subtraction, which means I'm going to add 1 to n. And then the second thing I'm going to do is I'm going to undo the multiplication by dividing. But the key point here is that I'm going to divide by the new exponent, which becomes n plus 1 after I add 1 to n. So if you look here at this antiderivative rule, you can see that's exactly what's happening. We're adding 1 to the exponent, and then we are dividing by the new exponent, and then there's the plus c that we discussed earlier. Now, when you take that rule into account, adding 1 and then dividing by the new exponent, we've got to carefully examine this last antiderivative rule, which is the antiderivative of 1 over u du, and that's equal to the natural log of the absolute value of u. Now, the reason we have absolute value bars is because we cannot take the log of anything that's negative, and so the absolute value bars protect against that. Now, here's how I would like you to see the integral of 1 over u du, is if you rewrite that using algebra, it becomes the integral of u to the minus 1 du. And then if you try to use your power rule, it doesn't work. Because if you increase the exponent by 1, it becomes 0, and then dividing by the new exponent becomes impossible. And so whenever you see something that's in the denominator to the first power, you need to think of the natural log rule. Okay, and it might be, again, helpful if you rewrite it as the integral of u to the negative 1 du. Now, indefinite integrals enjoy some nice properties. So, for example, this first one here, the integral of f of x plus or minus g of x dx can be separated into two different integrals, the integral of f of x dx here, plus or minus the integral of g of x dx. Now, I'm going to jump down to this note down here. Note that that cannot happen for multiplication or division. So I cannot take the integral of f divided by g and call that the integral of f divided by the integral of g. So on your notes, you may want to more emphatically put this little slash through the equal sign so you're clear that cannot be done with multiplication and division. And then going back to this second rule, we see that if there is a constant being multiplied by f of x, that constant can come in front of the integral sign, and we can just integrate the function itself and not worry about the constant. Okay, so let's see if we can apply some of these rules. We'll start with the integral of 3x squared minus 5x plus 4 dx. And so this is just the regular everyday power rule. We're going to increase the exponent by 1 and divide by the new exponent. So for that first term, we've got 3x to the third and then divided by the new exponent, which is 3, minus 5x to the second divided by the new exponent, which is 2, plus the antiderivative of 4, which will be 4x, and then please don't forget about plus c. And then simplifying that, 3 over 3 cancels, so it becomes x cubed minus 5 halves x squared plus 4x plus c. And honestly, probably most of you guys are going to be able to look at 3x squared and immediately realize that that is x cubed without having to say 3x cubed over 3. And I'm perfectly fine with that. If you were to skip this step right here and just go ahead and say x cubed, that would be perfectly fine. Okay, on the next problem just to the right here, the 5 over x is a problem. We cannot use the power rule if the x is in the denominator. So the first thing we need to do is rewrite this as x plus 5x to the negative 1. So taking the antiderivative one term at a time, the antiderivative of x will be 1/2 of x squared, or x squared over 2 if you want to say it that way. And then for 5x to the negative 1 here, if I increase the exponent by 1, it becomes 0, and then I would have to divide by 0. That is a red flag. I can't do that. And so that means it's not the power rule, it's the natural log rule. So the 5 is going to hang out in front. The antiderivative of x to the negative 1 is the natural log of the absolute value of x, and then plus c. Okay, for these next two problems, there is no product or quotient rule for antiderivatives, and so what we have to do first is we have to simplify. So this is going to become the integral of, we're going to just start multiplying here. So 2x times x becomes 2x squared, 2x times 3 becomes 6x, negative 1 times x becomes minus x, and then negative 1 times 3 is minus 3, and if you wanted to go ahead and collect the like terms there, that would say 2x squared plus 5x minus 3 dx, and then just start taking the antiderivative one term at a time. And so everything's ready to go here. I'm going to increase the exponent by 1 and divide by the new exponent, so that becomes 2/3 x cubed plus 5/2 x squared minus 3x, and then of course don't forget plus c. Okay, on the next problem, we're going to have to split through the numerator in order to be able to apply our antiderivative rule. So this is going to become the integral of x squared over x to the 1/2 minus 2x over x to the 1/2 plus 7 over x to the 1/2 dx. Okay, and simplifying further, this is going to be the integral of x squared over x to the 1/2, which becomes x to the 3/2 when I subtract the exponents, minus 2x to the 1/2, plus 7, and in this term, the x to the 1/2 is going to move to the numerator and become x to the negative 1/2. Okay, so now I'm ready to increase the exponent by 1 and divide by the new exponent. So the first term is going to become x to the 5 over 2, and then when I divide by 5 over 2, that's simply the same thing as multiplying by 2/5. So I'm basically multiplying by the reciprocal of the new exponent. Minus, the 2 is just going to hang out in front, and then x to the 1/2 is going to become x to the 3/2. Divided by 3/2 becomes the same thing as times 2/3. Plus, the 7 is going to hang out in the front. X to the negative 1/2 becomes x to the positive 1/2. And dividing by 1/2 is the same as multiplying by 2. And then, of course, don't forget plus c. And all of this is going to simplify to 2/5 x to the 5/2 minus 4/3 x to the 3/2 plus 14 x to the 1/2 plus c. Okay, in the next two examples, we're going to solve a differential equation. A differential equation is just an equation that involves a derivative. And so if you've ever wondered, hey, how do I figure out what c is? Well, here's the answer. You've got to be given what's called an initial condition. And so this f of 1 is equal to -3 is what we call an initial condition, and that's going to help us find what c is. And so if I want f of x here, that's my objective, is to figure out what the function f of x is. That's going to be the integral of f prime of x dx, which will be the integral of 6x squared dx. And so if I increase the exponent by 1, it becomes a 3. 6 divided by 3 becomes 2x cubed plus c. And this is my f of x function. Now, f of 1 is equal to -3 is going to help me find what c is. So I'm going to plug -3 in for f of x. I'm going to plug 1 in for x. And I'm going to solve for c. So I'm going to get -3 is equal to 2 plus c. So -5 will equal to c. And so that means the answer, the solution to this little basic differential equation will be 2x cubed minus 5. Okay, in the next problem, we're given f double prime, and again, asked to find what is f of x. And so now you notice we've been given two initial conditions, one for f prime of x, f prime of 0 is equal to 3, and one for f of x, f of 0 is equal to -2. Okay, so before I find f, I've got to find f prime. So f prime of x is going to equal to the antiderivative of f double prime of x dx, which is going to be the antiderivative of cosine x dx. And so the antiderivative of cosine will be positive sine x plus c. And if you'll remember this helpful little visual aid from earlier in the year, remember the derivative of sine is cosine, and then the derivative of cosine would be negative sine, and the derivative of negative sine would be negative cosine. So if you want to take derivatives, you go down this list. And so therefore, if you want antiderivatives, you just go up this list. And so you can see the antiderivative of cosine is positive sine. Okay, so now to find what this c is, we're going to use our initial condition for f prime of x. So f prime of 0 is going to equal to 3. I'm going to put f prime of x is equal to 3. So 3 sine of 0 plus c. And so that means that c will equal to 3. And so now I'm ready to do this process again by finding what f of x is, and that will equal the integral of sine of x plus 3. And so the antiderivative of sine, again going back over here to my helpful visual aid, here's sine, and so the antiderivative will be at the bottom of the list, which this time will be negative cosine of x. And then the antiderivative of 3 is just 3x, and then don't forget plus c. And so now we're ready to find what c is by using our other initial condition, which is the one right here. F of 0 is equal to -2. So -2 will go in for f of x, and 0 will go in for x, and then we'll solve for c. So cosine of 0 is 1, so this will be -2 is equal to -1 plus c, and so c will equal to -1, which means I'm ready to write my answer. F of x is equal to negative cosine x plus 3x minus 1, and that is the solution to the differential equation. Okay, the last problem for this section, very similar to the one that we just did, but it's in the context of particle motion. So for particle motion, I know that we have position. The derivative of position is velocity, and the derivative of velocity is acceleration. So again, if we're wanting to do, let's say that we're given acceleration, which is what we're given in this problem. We're given a of t is equal to 6t, and they eventually want me to get to the position. That means I've got to go up this list by taking antiderivatives. Okay, so v of t is what we're going to be able to find first, and I know that's the antiderivative of a of t, and so that's going to equal the antiderivative of 6t dt, which will be, increase the exponent by 1, it becomes a 2, divide by 2, 6 divided by 2 is 3, so this will be 3t squared, and then plus c. And so now we'll use our initial condition to find what that c is. And so our initial condition, it says that at time 0, the object's velocity is 10. So n for the velocity will go 10, and we'll set that equal to 3 times 0 squared plus c, which means that in that case c is equal to 10. And so now to find the position, we're going to take the antiderivative of the velocity, which is going to equal the antiderivative of 3t squared plus 10 dt. And so this will equal to, increase the exponent by 1, it becomes a 3, and then divide by 3 cancels the 3 that's there, so it becomes t cubed plus 10t plus c. Okay, now we're going to use our other initial condition, which is the object's position is 7, again at time 0, so 0 will go in for t, and 7 will go in for s of t. So 7 is going to equal to 0 cubed plus 10 times 0 plus c. And so again, that tells me that c is equal to 7. And so now I've got a position function, s of t is equal to t cubed plus 10t plus 7. And so now if I want the object's position at time t equals to 2, all I need to do is plug 2 into the position function. So s of 2 is going to equal to 2 cubed plus 10 times 2 plus 7, which will be 8 plus 20 plus 7 for a total of 35. Okay, so that'll do it for antiderivatives. If you guys have any questions, please feel free to let me know.